Hey, this is Tyson Bringhurst.
This is Nathan Northrup.
We're going to solve question 10.
Let's go ahead and share our screen real quick.
Okay. So in this question we have a trumpeter on a car tooting his horn at 565 hertz, driving towards this large building, and the sound waves are reflected back to the conductor on the same vehicle. There's a beat frequency of 7 hertz made from the combination of the waves from the trumpet and the reflected waves off the building. And so the question is, how fast is the vehicle moving?
Exactly. Well, so we'll start off by noting that the beat frequency means that the conductor is hearing a shifted frequency that's been shifted by 7 hertz. And so in this case, since he's moving towards the building,
F is going to be not greater than less than F prime.
Yeah. So in this case, he's going to be hearing a higher frequency.
Or 572 hertz. So you take 565 plus the 7 hertz difference, and then what the conductor is hearing is 572 hertz.
Exactly. So at this point, if we want to find out the velocity of the vehicle on which the conductor is standing, we need to take our basic equation for the Doppler effect, which is F prime equals F times the velocity of sound. And in this case, we're going to have actually two things happening here. So the sound wave is going to be being projected from the trumpet to the building and then bouncing back off. So we'll actually have two equations here. So the first one is, if we think about this from the perspective of the building, in essence what the building is hearing from the trumpet, you have the sound wave, velocity of sound, and since the building is still, then the velocity of the observer is 0, and the velocity of the source is what we're trying to find here. And for the perspective of the conductor, we have the frequency times, of course, the velocity of sound again. In this case, we're moving towards the building.
And in this case, we're using the frequency that the building observes as the source that the conductor hears. So when we take, we're going to take this right here. We're going to plug it in for F prime B. And that will give us FC prime equals the original frequency from the trumpet times the equation times this equation right here, Vx plus VR over Vs plus, Vs is the velocity of sound. So the nice thing is these cancel out, and then we get F equals this really nice equation. Now, velocity of the observer is equal to the velocity of the source, since they are on the same vehicle up here. So we can just use the same variable.
And since we know the shifted frequency, that's what the conductor hears, and the frequency at which the note was played, the only unknown left in this equation is the velocity of the observer, or the velocity of the vehicle on which they're traveling. So in order to solve for that,
it takes a lot of algebra, it's super long, but you end up getting equals velocity of sound minus trumpet frequency over the frequency of the conductor observes times the velocity of sound all over 1 plus the frequency over the frequency observed by the conductor. And when you calculate that out, that equals 2.11 meters per second. So this is the speed that the vehicle is traveling. That's it.